All right, here we're looking at section 9.1. We're starting our new unit with solving quadratic equations, but before we can solve them, we have to figure out some information about radicals. So our learning targets for today are to use properties of radicals to simplify expressions. Then we're going to simplify expressions by rationalizing the denominator, and we'll explain what that actually means and why we want to do that. And then we're going to perform some operations with radicals. So a radical expression is an expression that contains a radical, right? That makes sense. So a radical, right, is like our square root of something. This is a radical. So an expression, we want to get it always in simplest form. And I know that it's in simplest form when I've met these three bullet points. So no radicands, and the radicand is the stuff inside here, right? So if this has perfect and n powers as factor other than 1, okay, so this has to be fully simplified, and we'll go through several examples working on simplifying this. So no radicand contains fractions. I can't have any fractions in here. And no radicals appear in the denominator of a fraction. Once I've met those three things, then I know that it's in simplest form, and that's always going to be your goal. So if you're working through your homework and you get some questions wrong, double check that you are for sure in simplest form. So let's look at our product property of square roots. So the square root of a product equals the product of the square roots of the factors. Okay, let's break this down. So if I start with the square root of 9 times 5 is 45. Okay, so if I see that I have this square root of 45, this can be broken down, right? Because into the square root of 9 times the square root of 5 is what we're kind of showing here. Right? And I use 9 because I know what the square root of 9 is, right? The square root of 9 is 3. So when you're going through this and simplifying different things, when you're simplifying your radicals, you always want to ask, is this divisible by 4? Well, and I ask 4 because I know what the square root of 4 is. Then 9. I know what the square root of 9 is. Then I know that 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. These are going to be the big things that you're trying to divide out so you can simplify your radicals. Here we're looking at this same core concept just using letters. So if I have two things multiplied together underneath the radical sign, that's the same thing as the first one times the square root of the second one. Right? And as long as they're both greater than 0, this is true. So I can break things apart that are underneath my radical sign. So let's look at this example. So first I have the square root of 108. So I always want to figure out what is this divisible by? How can I simplify this? So I want to use my greatest perfect square factor, right? And you'll see the list on that last slide. Is it divisible by any of these things? Which is the biggest one that it's divisible by? Well, I know that 108 is divisible by 36. It's the same thing as 36 times 3. Then I can use that product property that we just learned to separate them out. Well, and then I simplify because I know the square root of 36 is 6. So now I end up with 6 times the square root of 3. And I know that this cannot be simplified any further. Okay, so now let's look at part B. So I see I'm multiplying several things underneath my radical sign, so I can simplify from there. So now I want to factor using my greatest perfect square factor. And I'm using squares because there's not a number outside here, right? So I'm using the square root. So I want twos of things. And I know what the square root of 9 is, and I know what the square root of x squared is, so I'm breaking this down, just like I did with the numbers up here. So now I can break them into, using my product property, separate them out. The square root of 9 times the square root of x squared times the square root of x. Well, I know what the square root of 9 is, and I know what the square root of x squared is, so I can simplify and write my final answer that way. So here are a couple I want you to try. You'll notice here on this number 2 that there's a negative sign, but it's out front, so that's fine. That can just stay out there. So I want you to try these and see how you can do. So here's our next core concept, the quotient property. Just like we did with the product property, right, when we were multiplying, I can do the same thing when I'm dividing. So if I take the square root of 3 over 4, right, I can break that into the square root of 3 divided by the square root of 4. And I know what the square root of 4 is, so I can get that square root out of the denominator and simplify. So just like we did when we were multiplying, I can do the same thing when I'm dividing. So let's look at this first example. I have the square root of 15 divided by the square root of 64. So I'm going to use my quotient property and break it into its pieces. Well, I know what the square root of 64 is, so then I can simplify. So let's look at B. and kind of do the same thing. So I see I have a fraction, so I want to use my quotient property to see if I can simplify it any further. So I break it into its pieces. Well, and then I can simplify because I know the square root of 81 and I know the square root of x squared, so I can fully simplify that. So now you'll see something a little bit different. Now I'm dealing with cube roots, and that just means I need 3 of something, right? I need to find cubes instead of those squares. So I'm going to use my perfect cube factor. And here I can have negative signs inside my radical because a negative times a negative times a negative will still get me this negative value. Okay, so this is just going to take some math practice of what the heck can I multiply by itself 3 times to get some of these values, right? So here I see that I have a negative 64 times 2. So then I use my property of cubes and I break it up, and I know that the cube root of a negative 64 is negative 4. And then I still have the cube root of 2 because that can't be simplified any further. So now let's look at this next example. Same sort of thing. What can I multiply by itself 3 times to get 125? Or can I break this into little pieces? And then I see that I have this x to the 7th right here. And I know that I'm going to pull out 3 at a time. So that can help me when I rewrite it. So I still have my cube root. I'm going to separate everything out, my numbers. If I pull out 3 at a time, right, I can have an x to the cube, x cubed times x cubed times x. Those are all the same thing. Then I simplify and I rewrite it each piece. Okay, so now I have the cube root of 125, the cube root of x to the 6th, and the cube root of x. From there I simplify. I know that the cube root of 125 is 5, because 5 times 5 is 25, times another 5 is this 125. The cube root of x to the 6th is x squared, because 6 divided by 3 gives me 2, and then I'm just left with this cube root of x that can't be simplified any further. So now let's look at this last example. I'm dealing with the cube root of y divided by 216. So first I want to use my quotient property and separate them out, and then I can simplify from there. I don't know what the cube root of y is, so that can stay there. And if I use my calculator, I'll find that the cube root of 216 is a whole number, is 6. So that's as simple as that can be as well. So now let's look at D. This is kind of lots of pieces going on here, and so we want to use everything that we've learned so far. So the first thing I do is I use my quotient property of cube roots. So I can look at the numerator as one thing, and I can look at the denominator as one thing. Then I'm going to factor out what I see and what I'm trying to pull out. So I factor out the numerator and I factor the denominator. Now I use my product property. So here we're using both properties in the same problem, and that is absolutely great. So I use my product property to kind of separate everything out, and now I can look at everything as one individual piece, because I know the cube root of 8, I know the cube root of x cubed, and I don't really know this, but I know that this is going to be simplified as much as possible. So from there I can simplify. I know the cube root of 8 is 2, and then I've got an x, and then I still have the cube root of x because I don't know what that is. The cube root of 27 is 3, and the cube root of y to the 3rd is y. So now I've got this as simple as possible after I broke it down into its each individual pieces, and that's always where we want to start. So now here are some that I want you to try and simplify as much as you can. So now here we're dealing with radicals in the denominator, and we really don't like having radicals in the denominator, so we're going to be rationalizing the denominator. That's our next learning target, and it's called rationalizing the denominator. So you see I have this radical, and I can't simplify this, right? I don't know what the square root of 3 is, and I don't know what the square root of n is, so that can't be simplified. So how do I get this radical out of the denominator? Well, I take my original problem and I multiply it by the square root of 3n over the square root of 3n, because this entire thing right here is equal to 1, right? When I divide something by itself, that's equal to 1. So I figure out what's in the denominator and multiply it by that. And so then, using my product property, if I have two things that are multiplying, I can multiply them together. So I end up with 15n, the square root of 15n in the numerator, and the square root of 9n squared in the denominator. Then I use my product property because I see that I can simplify this denominator. And when we're rationalizing, we always know that we're going to eventually simplify the denominator. So I end up with the square root of 9 times the square root of n squared, which can simplify to 3n, which you'll see is the stuff that's underneath my radical sign in my original problem. Okay, so now let's look at another example of this. So again, I see I have a radical in the denominator, and I can't have that and be as fully simplified, so I need to take care of that. So now I go ahead and multiply both the numerator and the denominator by the cube root of 3. And I use 3 here because that can help me simplify this denominator as well. If you want to use the cube root of 9, that works as well. You'll just have another step to simplify with. So now I use my product property of cube roots, right? And I just multiply those together. And then I can simplify. And I know that the cube root of 27 is 3. So this can also, you don't always have to use just the smallest one to multiply by. For me, to make my life a little easier, I would have multiplied by the cube root of 9, and then we can continue to simplify things as we go from there. Sometimes in the denominator you're going to have more than one term, and maybe only one of them is going to have a radical sign, and we still need to be able to simplify those. So you'll see I have a times the square root of b plus c times the square root of d, and then a times the square root of b minus c times the square root of d. These two things are called conjugates, and you'll see why they work here in just a minute. So when we have radical expressions in the denominator that look something like this, we can use the conjugate to help us simplify them. So here's our example, right? I have 7 over the quantity 2 minus the square root of 3. And I need to get rid of this radical in the denominator, but I see I have another term with it, so I have to use the conjugate. Okay? And so the conjugate of this 2 minus the square root of 3 is 2 plus the square root of 3. So I just change the sign that's in the middle, and that becomes my conjugate. So then I can use my sum and difference pattern, or I just multiply this out, right? All we're doing is multiplying two binomials. And so now, and I also know that this is the sum and difference pattern, right? Because I'm adding and subtracting. So I end up with 2 squared minus the square root of 3 squared. And then in the numerator, you see I have 7 times the quantity 2 plus the square root of 3. So I just multiply those, and now I can simplify. So I just multiply, distribute this 7, so 7 times 2 is 14. 7 times the square root of 3 is this 7 times the square root of 3. 2 squared minus the square root of 3 squared, right? So 2 squared is 4. The square root of 3 squared is 3. So that's why I'm doing this, so I can get rid of the radical sign. So I end up with 4 minus 3, which gives me 1. And then I can just get rid of the denominator for this one and simplify it to 14 plus 7 times the square root of 3. Now here are some to try. Really focus on these ones where you're going to need the conjugate to get rid of some of the radical signs. And really think about these and give them a good shot. So now we're going to be looking at some real life problems, okay? So the distance d in miles that you can see the horizon with your eye level h feet above the water is given by this radical expression. How far can you see when your eye level is 5 feet above the water? So all I have to do is I'm given an h value of 5, and I have to substitute that in. So then I end up with 3 times 5 over 2, which is 15 over 2. So once I have that, I can go ahead and use my quotient property, right, to split up the numerator and the denominator. Then I have to get rid of this radical in the denominator by rationalizing. So I multiply both the numerator and the denominator by the square root of 2. So then I can multiply. And I know that 15 times 2 is 30, and the square root of 2 times the square root of 2 gives me 2. This is as simple as I can get. And then I can plug this in my calculator. Most of the time we're going to want the exact answer. Whenever you see exact answer, plug this one in. If it says approximately or about, go ahead and use this. Go ahead and use your decimal. Okay? But first I had to separate them all and then simplify and rationalize my denominator here. Okay, so here's our another one that we can model with this. So the ratio of the length to the width of a golden rectangle is the quantity 1 plus the square root of 5 to 2, right? And we write ratios with a colon in between. The dimensions of the face of the Parthenon in Greece form a golden rectangle. So I'm given some information there. What is the height of the Parthenon? Because I'm given the width right up here. Well, so first of all, I have to use this ratio that I was given. All right, and when we're using ratios, I can set them up as fractions. So I have 1 plus the square root of 5 over 2, right? So I've got length to width equals length to width right here. Okay, so I write my proportions, and then I can cross multiply. So I've got h times this quantity, and then 62, so 2 times 31. Then I can divide each side by that ratio, by that 1 plus the square root of 5. Well, now I see I have a radical in my denominator again, so I'm going to have to use the conjugate here, which would be 1 minus the square root of 5. So I multiply both the numerator and the denominator by that conjugate. Then I can simplify. So now I'm going to have 62 times 1 and 62 times a negative square root of 5, which is where I get this numerator. And remember, when I'm dealing with the denominator, I have this 1 squared and then my minus this second term squared. And the square root of 5 squared is going to be 5. So I'm going to end up with 1 minus 5, which gives me this negative 4. Then I can use a calculator because I was given a whole number here, and so I want to know my approximation. So I use my calculator, and then I finish with my full sentence. The height is about 19 meters. And I want to look and just double check, does that make sense? Well, if the length is 31, could the height be 19? Yeah, that mathematically would make some sense. So I know I'm on the right track. Okay, so now here are a couple of word problems that I want you to try. The first step we always want to kind of do is draw them out, especially this number 22. Draw it out and see what things you're actually looking at and then what you can do with it. So now we're going to be doing some operations, performing some operations with our radicals. This is our last learning target. So here you'll see I have 5 times the square root of 7 plus the square root of 11 minus 8 times the square root of 7. So I know that I can't add them just like, I don't want to put these in the calculator. I want to keep my exact values. So I know I have to simplify and then combine like terms. So the first thing I want to do is I want to use my commutative property of addition, which just rearranges my terms. So I want to get everything that has a square root of 7 together and then everything else that's similar together as well. So now I can use my distributive property. This is like saying the square root of 7 is like apples and the square root of 11 is like oranges. They're different things. So if I have 5 apples minus 8 apples, I end up with negative 3 apples plus the square root of 11. These two things are very different, so I can't combine them when I'm adding or subtracting. So now let's look at the second example. First, I see that this is a radical that I can simplify and write in a different form. So the first thing I have to do is I have to factor this one out. I leave the first one alone because 5 is as simple as it gets and I can't factor 5. So I factor this square root of 20 using the number 4 because I know that 4 is a perfect square. So then I use my product property and separate them out, and I kind of simplify from there because I know the square root of 4 is the same thing as 2. So now that I have these radicals with the same number inside, now I can simplify and I can combine my like terms. So now I've got 10 plus 2, which gives me 12 square root of 5. So I always want to first make sure that my radicals are as simple as I can get them, and then I can go ahead and add or subtract or combine them. So now here we're using cube roots, and we follow the same pattern. So I see that the stuff inside my cube root is the same. I have an x and an x, so now I can go ahead and simplify. So I have 6 plus 2, which gives me 8 cube roots of x. So now this is as simple as I can get it. So now what happens if I'm multiplying radicals, right? So we just looked at some adding and subtracting. So now what if we multiply? And here you'll see I have something outside parentheses and some stuff inside. So I can go ahead and use my distributive property to go ahead and rewrite that out. So now I've got square root of 5 times the square root of 3 minus the square root of 5 times the square root of 75. Then I use my product property and I actually multiply those out. So I see that neither of these is as simple as possible, right? So I want to kind of simplify. If I was to factor out 15, I can only use 5 and 3, and I don't know the square root of either of those, so 15 is as simple as it can be. So here I see that this can be divisible by 20. This is divisible by 25, right? So that helps me pull out a 5, and then there's 15 left inside. So I simplify. So now I see I have the square root of 15 minus 5 times the square root of 15, which ends up being negative 4 times the square root of 15. That's one way we can do it. So the second way we can do this is to first simplify the square root of 75. And sometimes this is easier to simplify when your numbers are smaller. So I go ahead and I simplify the square root of 75 because I know right off the bat that 75 is divisible by 25. which allows me to then, here, let's just look at it real fast. So this turns into the square root of 25 times the square root of 3, because 25 times 3 gives me 75. Well, I know what the square root of 25 is. The square root of 25 is 5, and I'm left with the square root of 3. That's where I get this value from. So now that we've simplified first, now I can go ahead and use my distributive property, and I then subtract. So what we did was we took care of what was inside here first, and then I just use my product property of square roots, so then I can just multiply those together. Either way, I end up with the same answer, but oftentimes it's easier to simplify first before we start multiplying and have more things to simplify later on. So here's your final monitoring progress. Try a couple of these and see how you can do. Definitely make sure you're adding and subtracting a couple, and then try some of these multiplying ones. Especially this number 27. What do we do if I have this squared outside? How would I deal with that one? So now let's look back at our learning targets and see how we did. Our first learning target today was to use properties of radicals to simplify expressions. And the properties that we really looked at were the product and quotient properties. Then we were able to simplify expressions by rationalizing the denominator, because we don't ever like a radical in the denominator. And then we performed some operations. We added and subtracted and multiplied different radicals together. So now that we've tried all of these and gone through some examples, now go ahead and work on that homework for 9.1.